Okay, let's talk about the 8080. The 8080 is an 8-bit microprocessor that was released in April of 1974. At the time it was released, it cost about $360 per chip. It has an 8-bit data bus, 16-bit address bus. There are 7 general purpose registers: the B, C, D, E, H, L, and the accumulator. For 16-bit operations, those 8-bit registers can be paired up: the BC pair, the DE pair, and the HL pair. For the special purpose registers, there's a stack pointer, a program counter, a status register. The instructions, there's 246 instructions. They include arithmetic, logic, control, and data transfer. Typical instruction length is 1 to 3 bytes. Depends on which instruction you're executing. Clock speed is up to 4 megahertz. Typically they run around 2 megahertz. It takes 4 to 18 clock cycles per machine cycle. And that also brings up the fact that this does not have an internal oscillator or clock generator. You have to use an external IC to provide the clocks. Another thing is regarding power supply. This needs +5, -5, and +12 power supplies. So it's not exactly, it wasn't exactly easy to interface at the time because of the complexity of the power supplies. The ALU, Arithmetic Logic Unit, performs 8-bit arithmetic, add, subtract, increment, and decrement, and of course logic functions, and, or, XOR, and compare operations. You can operate on the accumulator or other registers or memory. Let's see, the register file, we've got general purpose registers can also serve as address pointers, and the HL pair is often used as an indirect address pointer. Regarding the stack, it supports subroutines with call and return instructions, and it uses external memory for the stack via the stack pointer. It supports interrupts. 5 hardware interrupts. There's a trap, which is non-maskable. You have RST 7.5, RST 6.5, and RST 5.5, and then one interrupt that is maskable. The interrupts are vectored, enabling fast branching to fixed locations. That will come in handy in the programming of the part. And that's essential for real-time processing and I/O handling. The 8080 uses isolated I/O, uses in and out instructions, so you can address 256 input and 256 output ports separately from the memory space. Control signals, there's read, write, I/O, and memory to differentiate between memory and I/O accesses. A ready line for wait state insertion to synchronize with slower peripherals and such. And then an address latch enable for demuxing address and data bus. The physical implementation was built in NMOS technology. It's packaged in a 40-pin DIP package. And as I said before, it requires multiple power supply voltages, plus and minus 5 and plus 12. The 8080 uses assembly language as its low level, but it's relatively powerful for its time. It can do conditional and unconditional branching, looping constructs using decrement and jump, memory indirect address via the HL register pair, and subroutine call stack management. The 8080 was really first, was really first successfully used in the Altair 8800. That was the first real solid application that this device found use in. And I think that's probably about it for this one. I've got a few more bits on some of the peripheral devices, the clock generator and such, and I will include those in the next installment. So until that time, I will see you later.